Why can't you relax, even when you finally have time to rest? You sit down, you stop working, but your mind keeps moving. Your body feels tense, your thoughts keep running, and you never feel fully at ease. This is not just a habit, it is a neurobiological state. Relaxation is not simply the absence of activity. It is an active process regulated by your nervous system, your brain networks, and your hormonal balance. To understand why you can't relax, we need to start with the autonomic nervous system. This system has two major branches: the sympathetic system, which activates your body for action, and the parasympathetic system, which allows recovery and restoration. In a healthy state, your body moves fluidly between these two. But in chronic stress, this balance is disrupted. The sympathetic system remains dominant. Your body stays in a state of readiness, even when there is no immediate threat. Now let's connect this to the brain. The amygdala plays a central role in detecting potential threats. Under repeated stress, its sensitivity increases, meaning it begins to respond not only to real danger, but also to uncertainty and internal thoughts. At the same time, the prefrontal cortex, which normally regulates emotional responses and suppresses unnecessary activation, becomes less effective under prolonged stress. This creates a state of reduced top-down control and increased bottom-up reactivity. In other words, your brain becomes better at detecting stress and worse at shutting it down. Now let's go deeper into the stress system. The HPA axis, linking the hypothalamus, pituitary gland, and adrenal glands, controls the release of cortisol. Under acute stress, cortisol is adaptive. But when stress becomes chronic, cortisol levels remain elevated or dysregulated, disrupting normal circadian rhythms. This affects sleep, recovery, and baseline arousal. Even when you try to relax, your body is still chemically prepared for action. Now let's introduce hypervigilance. Hypervigilance is a state where your brain continuously scans for potential threats. This is common in individuals exposed to prolonged stress or high-demand environments. The brain prioritizes safety over relaxation. So even in safe conditions, it does not fully deactivate. Now consider the role of interoception. Your brain constantly monitors internal bodily signals, such as heart rate and muscle tension. When your body remains slightly activated, your brain interprets these signals as something is wrong, reinforcing the stress response. This creates a feedback loop. Body tension, perceived threat, increased tension. Now let's connect this to modern life. Constant stimulation from devices, notifications, and information keeps your brain engaged. Your nervous system rarely enters a true recovery state. Even during rest, your brain is still processing. Now consider the default mode network. This network becomes active during rest and is essential for self-reflection, emotional processing, and memory consolidation. But if your brain is constantly stimulated or hypervigilant, it cannot enter this state effectively. So recovery does not occur. Now let's bring in psychology. One key factor is perceived control. When your brain believes that outcomes are uncertain or uncontrollable, it maintains activation to prepare for potential outcomes. This increases baseline stress. Another factor is cognitive rumination. Your brain attempts to resolve unresolved problems by repeatedly thinking about them. But this process often becomes cyclical, not productive. Now consider behavioral conditioning. If your brain has learned that relaxation is followed by stress, such as checking your phone or thinking about work, it begins to associate rest with activation. So, relaxation itself becomes uncomfortable. Now here is the key insight. You cannot relax, not because you're doing something wrong, but because your system is calibrated for activation. Relaxation requires recalibration. Now, how do you change this? First, you must reduce baseline activation. This means reducing continuous input, not just workload. Second, you must activate the parasympathetic system. Slow breathing, controlled movement, and low-intensity activity can shift your nervous system toward recovery. Third, you must retrain attention. Your brain needs to experience sustained periods without switching or stimulation. Fourth, you must tolerate stillness. At first, relaxation feels uncomfortable because your system is not used to it. But this discomfort is part of the recalibration process. Fifth, you must rebuild safety. Your brain needs repeated evidence that it is safe to deactivate. This takes time. And finally, you must understand that relaxation is not passive. It is a skill, a biological process. And like any system, it can be trained. Your brain is not broken. It is adapting. But adaptation can be reversed. And when it is, calm return. If you found this helpful, subscribe to Nexplain